Music, a universal language that resonates with the soul. But beneath every note, rhythm, and harmony lies an intricate language of mathematics. From the timing of beats to the structure of scales, math serves as an unseen framework that shapes the music we cherish. Whether it's the precision required for tuning the instrument, the rhythmic pattern we dance to, or the symmetry woven into musical composition. Mathematics acts as an invisible architect of sound. In this documentary, we will delve into captivating relationship between numbers and notes, uncovering how math and music converge to create the art we love. Join us on a journey into the realm where math meets music, revealing the profound ways these seemingly disparate fields are intertwined in ways you might never have imagined.
The relationship between sound and mathematics is deep and complex, reflecting the fact that both disciplines are ultimately founded upon the same abstract language. Indeed, music is in some ways built on the foundation of mathematics because sound itself is a mathematical phenomenon. Musical scales are an excellent example of this. They are constructed with such careful consideration for the properties of the accompanying intervals, with which they share a common ancestry that they can be defined by simple, precise frequency ratios. An octave, for instance, is simply the doubling of a frequency, and as such, it can be expressed as a simple ratio of 2 to 1. And a perfect fifth is a ratio of 3 to 2. And this is just the beginning. Music is also governed by mathematical rules when it comes to rhythm. Time signatures define how many beats there are in each measure and the relative value assigned to each note in that measure.
Going beyond the basics, we can study music on more abstract level, revealing how the language of mathematics is woven into music theory and practice. Patterns and relationship are pervasive across cultures, with early instruments evolving from simple tools into sophisticated devices specifically tuned to produce harmonious sounds. The mechanics of creating musical tones, whether through vocal cords in the instruments, also reflect recurring mathematical models. Cooling air creates organ-like timbre, black string mimic bell-like sounds, and synthesized tones imitate square wave patterns. Moreover, mathematics has long played a subtle but crucial role in music composition. Johann Sebastian Bach, a master of counterpoint, used mathematical precision to weave independent musical lines together, creating complex and harmonious structures in work like his fugues. This intertwining of melodies follows strict rule-governed principles reflecting an almost geometric order. In the 20th century, composers like Arnold Schoenberg pushed this mathematical connection further with a 12-tone technique by organizing all 12 notes of the chromatic scale into sequences. Without traditional tonal hierarchies, Schoenberg developed a mathematically structured approach that reshaped modern music, reflecting the intricate relationship between numbers and sound.
Mathematics isn't just for scientists. It's also foundation of a creative expression, especially in music. So music follows a mathematical patterns from the simple ratios that create harmony to the intricate rhythms and melodies that captivate us. So math is the invisible structure that shapes the sound we love. So looking ahead, AI and algorithms are transforming music further. They're just not tools, but partners in the creative process, pushing boundaries of what we can imagine in sound. So in both math and music, we see a universal language, one built on patterns, connecting logic and creativity in powerful ways.